How do you get feature importances for nonlinear models? Let's talk about model interpretability beyond linear models. We will be looking at 3 ways for model interpretability. First, scikit-learn's feature importances if you are using scikit-learn models. Second, LE5, and third, SHARP. Let's start with sklearn's feature importances. For linear models, we get feature importances using this .coef _ attribute. But for other models, scikit-learn has this feature importances attribute. Now it's calculated in a different way for different algorithms. For example, for tree-based models, it's calculated based on impurity. That is Gini index or information gain. And for tree-based models, it kind of makes sense because we are actually making the split based on the most important feature. So we can get this information about feature importances for tree-based models. For algorithms such as KNN or SVM-RBF, scikit-learn doesn't have feature importances attribute. Now, I'm not exactly sure how it's calculated for random forest, but it will be based on impurity. And if you want to know the details, you can either look in the documentation or in the code. Let's create and fit a pipeline with preprocessor and random forest. I'm fitting the pipeline, and here are our feature importances for random forest. I'm using this feature importances attribute for random forest, and these are the feature importances. So according to our random forest, this FNL WGT is the most important feature, followed by age, education, capital gain. Okay, so that's good to know. A key point here is that unlike linear model coefficients, feature importances do not have a sign. They tell us about the importance, but they don't actually tell us in what direction the feature is going to affect the prediction. And this kind of makes sense because our relationship is not linear anymore. Our model is not linear. In linear models, it makes sense to tell this direction that, okay, if you increase the value of this feature, then your prediction is going to change in this direction. Or if you decrease the value of this feature, then the prediction is going to change in this other direction. But in nonlinear models, it might happen that increasing a feature may cause the prediction to first go up and then go down because it is a nonlinear model. So yeah, the key point is that there is no sign to these coefficients. We do not see any sign here. Let's check whether these importances match with importances identified by logistic regression model. So I'm showing you feature importances by random forest model and feature importances by logistic regression model. We see that both these models agree on age, education, and capital gain. But this particular feature, for instance, FNL WGT, according to random forest, it is an important feature, but according to logistic regression model, it's not that important. And also note that these actual numbers for feature importances, they are not really comparable. So if you look at actual numbers for random forest versus actual weights for logistic regression, you shouldn't really be comparing these numbers. How can we get feature importances for non-sklearn models? For scikit-learn models, we can use feature importances attribute, but last lecture, for instance, we saw these best performing models like GBM and XGBoost. They are not scikit-learn models. So how do we find feature importances for that? One way to do it is by using this tool called LE5. If you want to use this tool, you will have to install it. I have this command and a link to their documentation here. Let's look at feature importances for XGBoost classifier. I'm importing LE5 first, then I'm creating a pipeline with our preprocessor and XGBoost classifier. I'm fitting the pipeline and I'm calling explain weights on LE5. I'm passing our XGBoost classifier and feature names to it. And these are our feature importances for XGBoost classifier. Now, according to this model, the top feature is different compared to what we saw for random forest. For random forest, the top feature was this FNL-WGT. Okay, but I think all models seem to agree on this capital gain feature. Again, all these weights, all these feature importances, they do not have any sign. Now let's try it out for light GBM. And it also has these nice colors here. And light GBM seems kind of similar to our XGBoost model. So according to both of them, this married CIV spouse, so that marital status, I think that seems to be an important feature. And capital gain, education, and age, I think these are important features for almost all models that we have seen so far. And of course, you can also look at feature importances for random forest classifier. And here are the feature importances given by LE5 for random forest classifier. And we can also compare them with what we got before, with our feature importances of scikit-learn. And if you compare these two numbers, so it seems like they are using the same algorithm to find feature importances. So this is good. The approaches that we have seen so far, they tell us globally about which features are important. But what if we want to explain a specific prediction? Suppose we train a model and we are using this model, and now we have a new test example and the model gives us some prediction. Now we want to find out why the model gave this specific prediction, which features contributed to this prediction. There are some fancier tools which can help us with this. And in the next video, we will talk about one of such tools called Sharp.